Hello students, welcome to Educate. In the last class of the chapter Biomolecules, we have discussed till the classification of carbohydrate. Now we will discuss about the glucose. Already you know glucose is an aldose since there is an aldehyde group present in the glucose. It is hexose. It's hexose means it is composed of 6 carbon atom. Now about the glucose we will discuss in the detail. Let's see. First of all is preparation. Preparation first here is glucose. Method of preparation of glucose from sucrose. Sucrose, it is called kitchen sugar, because we uses in our kitchen the sugar which we called, that is actually the kitchen sugar. So here first of all, see, you already know that sucrose is composed of glucose and fructose. So what is here from the sucrose, if we hydrolyze the sucrose, then we will get glucose and fructose. So in this way we can prepare the glucose. The fructose can be separated from there, then we will get glucose. Okay, let's see. So first it was this one from sucrose, and how that is goes on the reaction. So let's see. Here it's sucrose. Here sucrose C formula will be C12H22O11. The formula of glucose is sucrose is C12H22O11. Because and the formula of glucose as well as fructose is C6H12O6. This one here, this reaction. So what is here? C6, when water will get added in this compound, then both glucose and fructose will get separate from there. Okay, so let's see here what's the written in the comment box initially, or what's the written here about the comment. That is here HCl. During the hydrolysis we will have to add a small amount of HCl and H2SO4 in alcoholic solution. Okay, hydrolyzed here, keep in the mind that you will not have to take water. Actually water will be also there. So in alcohol you will have to take alcohol, water and a small amount of HCl or H2SO4. That is, so when you will hydrolyze that, there will be formation of glucose and fructose, in which you can separate the glucose from the fructose. Next one is starch. From the starch, you know, that is a polysaccharide, and starch is made up of a number of glucose. So when you will hydrolyze the starch, then it will dissociate into a number of glucose molecule. So one method is hydrolyzing the starch. So hydrolysis, you do the starch, again you will have to take dilute H2SO4 here. So a number of glucose will form. That is how you will prepare the glucose. One is from kitchen sugar and second one is starch. Sucrose, that is made up of glucose and fructose. So obviously when we hydrolyze the sucrose, we will get glucose and fructose, of which glucose will be separated from fructose. Second one is when we hydrolyze the starch. The starch is a polysaccharide, that is, it is composed of a number of glucose molecule. So when we hydrolyze the glucose molecule, the starch, then we will get a number of glucose molecule. Okay, that was about the preparation, how we will prepare the glucose. Second one is, what is the structure of glucose? Now we will discuss about the structure of glucose. Here two forms, that means some of the phenomena indicates that glucose has open structure, and that's why the stick form structure of glucose has been proposed. And some phenomena, that is some reactions, indicates that the glucose has closed structure, that is that the glucose have cyclic structure. So that is, and its structure resembles with that of paranose. That's why that is called paranose form of structure. So two forms of structure has been proposed about the structure of glucose. One is stick form, and second one is stick form, and the second one is cyclic form, of which here there are some reactions which indicate that the glucose has open structure, that is, and that's why the stick form structure has been proposed. So let's see, first of all, what's the reaction here. About this one, its molecular formula is C6H12. How's? So that's the reaction is given here. How's that? That is about the glucose, when that will be treated with HI. When glucose will be treated with HI, there will be formation of hexane. So hexane form, that means here glucose is made up of 6 carbon atoms. When the glucose was heated with HI, there was formation of hexane. That's indicate that glucose is composed of 6 carbon. Okay. Second one is here. Second one is when glucose reacts with hydroxylamine. You are already aware in the chapter of aldehyde and ketone. Hydroxylamine, when react with the aldehydic or the ketonic group, hydroxylamine reacts with aldehydic or ketonic group, and there will be formation of imine, hydroxylamine. So let's see here what happened here. If when NH2 bonded there is formation of this compound. How? Because hydrogen of this NH2, both the hydrogen of this NH2 combine with this oxygen and form H2O, and this nitrogen get bonded to this carbon. Listen again, that in hydroxylamine here, there is 2 hydrogen atom of NH2. At the NH2 there is 2 hydrogen. Both this hydrogen will combine to this oxygen. In detail, if you want to go why that is happened, so that's refer to the chapter of aldehyde and ketone. So both the hydrogen of bonded to the nitrogen will combine to this oxygen and form H2O. So 2 valency of this carbon atom will become destabilized, and that of the nitrogen atom. So that's why there will be double bond formation between this carbon and this nitrogen, and OH remain attached to this nitrogen. So that's why this compound has been formed. So it indicates that when the glucose was reacted with, when glucose was reacted with hydroxylamine, there is formation of this compound, this oxime form. That indicates that since there is formation of an oxime, so that's indicate that glucose contained acyclic carbon atom. That is here. Then after, when another reaction is also that when the glucose react with HCN, then there be formation of, glucose react with HCN, there will be formation of cyanohydrine. How is that? Oxygen here attached here, oxygen which is doubly bonded to this carbon atom. If feeling difficulty, then refer to the chapter of aldehyde, ketone and carboxylic acid. Here, so that's why I am telling here in the short. This oxygen is doubly bonded to this carbon. So this carbon will take out the electron, will attract the pi electron towards itself. So this oxygen will have negative charge, this carbon will have positive charge. Of HCN, the hydrogen will get bonded to this oxygen because there is negative charge and hydrogen has positive charge. So hydrogen will get bond to this oxygen, and of Cn minus, so carbon will get bonded to this carbon because carbon-carbon bond is stronger. So carbon-carbon bond is stronger. So this Cn will get bonded to this carbon. So as a result, there is formation of cyanohydrin. So cyanohydrin form here. So it also indicates that the glucose contain acyclic carbon atom. It's indicated, first one here indicates that glucose is composed of 6 carbon. Second reaction indicates that is here, second one, that is reaction with hydroxylamine and hydrogen cyanide. That indicates that the glucose contain acyclic carbon atom. Okay guys, here first one indicates that this reaction, glucose when react with hydroxylamine or HCl, that indicates that glucose contain acyclic carbon atom. Second one is here, when you will oxidize, when glucose was oxidized by the bromine water, there is formation of gluconic acid. CHO group has been oxidized into COOH. You already know, when aldehyde group will oxidize or the ketonic group will oxidize, there will be formation of carboxylic acid. Ketone will oxidize to form carboxylic acid, but there will be dissociation of bonds at some places. So aldehyde get oxidized to form carboxylic acid. So here the CHO group oxidized into COOH group. So that's indicate that glucose is an aldose. That is, glucose contain here the aldehydic group. Okay, when the glucose will react with acetic anhydride. About the acetic anhydride reactions, you know already that the hydrogen, acetic anhydride like structure is like that. Acetic anhydride, this one. So you have already studied that in glucose, that means alcohol, when reacted with the acetic anhydride, then what happens? Hydrogen get bonded to this oxygen, which is bonded to both the carbon atom. With that oxygen, the hydrogen get bonded. This hydrogen will get bonded. So bond will dissociate from here, and when bond will dissociate from here, this hydrogen will get bonded to this carbon. So bond will get dissociated from here. This here once again I did the mistake. That is here. Listen once again. This hydrogen, acetic anhydride is this one, CH3, C double bond O, O, C double bond O, CH3. So hydrogen of this one get bonded to this oxygen. So bond will get dissociated from here, and that become acetic acid, that is CH3, COOH, and this acyclic carbon atom will get bonded to this oxygen, because when bond will dissociate, here will be positive charge to this carbon atom. H plus will get bond to this oxygen. So during that course, the oxygen will take the electron of its own as well as of that carbon atom also, and that will this oxygen will donate that electron to the hydrogen. So acetic acid will form there, and this acyclic carbon atom will acquire the positive charge, and this oxygen has the negative charge. That's why this acyclic carbon atom will get bonded to this oxygen. So this one, and at that means here, as in this compound, there is this compound form here. Since there is formation of glucose pentaacetate, that means indicates that in glucose there will be OH group. that is hydroxyl group at the 4 carbon. So here previous one, first reactions, here first reaction indicate that the glucose is composed of 6 carbon atom, that is reaction with HI, reaction with hydroxylamine as well as with HCN indicates that glucose contain acylic carbon atom. Reaction when oxidized by the bromine water, then there is formation of gluconic acid, which indicates that the glucose is composed of aldehyde. When that will be treated with acetic anhydride, that indicates that glucose, in the glucose there will be 4 hydroxyl group. And next reaction here, when the oxidation of the glucose will be done, there is formation of sacharic acid. When glucose was oxidized, then there is formation of sacharic acid. Hence, the CHO group at the terminal end, this CHO group get oxidized into COH, and the terminal carbon atom, that's also oxidized into COOH group. So that indicates that there will be OH group at the primary carbon atom. As glucose was oxidized, then there was formation of sacharic acid. That indicates that in glucose there is an OH bonded to the primary carbon atom. So that is here sacharic acid. Same thing happened about the gluconic acid also. In gluconic acid, here this COH already here. So when we oxidize the gluconic acid, then of the this 6 carbon, that also oxidized and give sacharic acid. Already this is oxidized, and this one get oxidized into COH group. So here what is that? So this reaction indicates that in glucose there is an OH group attached to the primary carbon atom. Okay, just recall here again, the reaction with HI indicates that the glucose is made up of 6 carbon atom. So that indicates that glucose is a hexose. Second one, when glucose was treated with hydroxylamine, then that indicates that the glucose contain an acylic carbon atom. Same, when glucose was treated with HCN, there was again indication that the glucose contained an acylic carbon atom. When the glucose was oxidized by bromine water, that indicates that the glucose contained an aldehydic group. And when the glucose was oxidized again, then there is formation of sacharic acid. So here of the sacharic acid, and same, the cis-gluconic acid also gives sacharic acid. So reaction oxidation here, that indicates that in the glucose there is an OH bonded to primary carbon atom. Okay, that was here. Now there are one question arise, there one concept is here. Plus sign indicates for the glucose. We indicate the plus sign for the glucose. Why plus sign? So here plus sign or the minus sign or D, or as well D and L. Plus sign and minus sign or D and L. That indicates that the compound is dextrorotatory or levorotatory. A small d, not capital D. That is D here or plus sign. If that is here, that means it indicates that the compound is dextrorotatory. And L or minus sign, that indicates that the compound is levorotatory. Guys, if there be a symmetric carbon atom and some other concept is there, that is about the symmetry, you can predict that the compound is optically active or not. But by simply watching that, you cannot say the compound is dextrorotatory or levorotatory. The dextrorotatory compound it is or levorotatory it is, that can be done, that can be predicted only by doing the experiment. So here optical activity of the compound is an experimentally determined quantity. So here first one is about that we use the D or plus sign, a small d or plus sign. We usually indicate plus sign for the glucose. That indicates that glucose is a dextrorotatory compound. Glucose is a dextrorotatory compound, and that has been predicted by doing the experiment. That is, the plane polarized light was passed through the glucose, and it was observed that the plane polarized light rotates towards the right. So that indicates that is plus sign. Another factor arises that capital D we use for the glucose. You have seen in the market glucon D. In the market, glucose which you have purchased the glucose, watch out what's the written on the wrapper in the bold, and that's in the heading, that's written glucon D. Another one we have never seen, glucon C, glucon P, or like that. That is not here. Why glucon D? Because we use the D sign for glucose. And here D sign, right now I am telling you, D sign indicates that at the second last carbon atom, OH is towards right hand side. Why that one? We just discuss. Just I am discussing about that. Okay, this is a glyceraldehyde. Glyceraldehyde. Glyceraldehyde it is. In glyceraldehyde here CHO, that is 1, 2, 3 carbon here, and the OH here. So glyceraldehyde can be indicated in two forms here. That is, in one case the OH is towards right, and in another case the OH is towards left. So the compound in which the OH is towards right, that is plus sign, that's indicated by the plus sign, that is dextrorotatory compound. In glyceraldehyde, in case of glyceraldehyde, the compound in which the OH is towards right side, that is dextrorotatory compound, and the glyceraldehyde in which the OH is towards left hand side, that is levorotatory compound. And when this configuration has been drawn, then for the dextrorotatory compound there was capital D, and that is here, that has been capital D, and so, and for levo that is capital L. So that's why here in case of glucose, again we will draw the structure. Okay, right now here let's see, when we draw the structure of glucose, so it will be here, this one, in glucose also, thus OH group is towards right hand side. The OH group at the second last carbon atom is towards right hand side, and that's why it is indicated by capital E, capital D. Okay, capital D. When you draw the structure, then you will find out that D, that means OH at the second last carbon atom is towards right hand side, and that's why it is indicated by D. And plus sign indicated by glucose, because plus sign indicated by the glucose, because glucose is a dextrorotatory compound. Okay, So this is here. Now that was about the deep, this one. Now I am telling you in the detail how to draw the structure of glucose. Might be you have find out here, but again I am telling you how to draw the structure. So first of all, you already know the glyceraldehyde is hexose, so that will be composed of 6 carbon. So first of all, 6 carbon atom here. After that, you also know that glucose contains acylic carbon atom, and not only that, you have realized that glucose contain aldehydic group. So aldehydic group means the acylic carbon atom will be at the first carbon. So at the first carbon, there will be acylic carbon. So here double bond O and here hydrogen. Here about the structure of this one. Earlier one, in the earlier compounds, you have drawn the structure of the compound according to your convenience. According to your convenience, and I also, when I was teaching you how to predict the product during a reaction, then I have drawn the structure of that compound according to my convenience. Here, because in those compounds, there was optically, we were not considering about the optical activity. So three-dimensional geometry have not any relevance in those cases. But in these compounds, in the carbohydrate, the three-dimensional geometry has a wide relevance. Because in the carbohydrate, one of the important condition is that the compound should be optical active. The compound should be optically active. So, and in the definition also you have studied that the optically active compounds which contain an aldehyde group or a ketone group and more than one hydroxyl group, that is carbohydrate. So optical activity, further optical activity, the structure in three-dimensional geometry, or in other word, the configuration does matter. So that's why we will have to consider about that. So here aldehyde group, OH, then after OH how to find? So right, left, right, right. That's keep in your mind. Right, left, right, right. Or in other case, the OH group will be towards left hand side at only third carbon atom. And in other cases, in other carbon atom, the OH group will be towards right hand side. Guys, keep in your mind in which direction you will have to draw the OH group. As in case of glyceraldehyde, the three-dimensional in OH was towards left hand side or towards right hand side. OH was towards left hand side or towards left hand side. That was indicating the compound will be optically dextrorotatory or the levorotatory. So let's see here. So at the third carbon atom, the OH will be towards left hand side, and in other word, that will be towards right hand side. So let's see here. You have primary carbon here, so only CH2OH here. So when you will have to draw the structure of glucose, only you will have to keep a stick form of glucose. In the examination, usually a stick form of glucose don't ask. In the 12th board examination, usually questions don't ask that draw the stick form of the structure of glucose. That's usually asked, draw the Paranose form of the structure of glucose in the 12th board examination. But the stick form structure of the glucose could be asked in the upcoming examination also. Okay, and but it's a stick form structure of glucose has the significance for IIT main something and IIT NEET examination and in CUET examination. Predominantly in CUET examination and in NEET examination about the structure of glucose stick form structure of glucose could be asked. Okay, so that is here. So you will have to keep in the mind only when you draw the structure that in glucose the OH group will be towards left hand side only at the third carbon atom. First, second, and it is this. Oh, sorry guys, here I have written OH. It will be not OH, it will be hydrogen. Okay, so what happened? The OH group will be towards left hand side only at the third carbon atom, and in other remaining carbon atom the OH group will be towards right hand side. So its structure is, what is the structure? It is stick form a structure of D plus inside the bracket and glucose. Here D, because the OH group at the second last carbon atom is towards right hand side, and plus sign because glucose is dextrorotatory compound. Okay guys, clear here? That was stick form structure of glucose. So that has been drawn here. So let's see what's in the book here. D plus glyceraldehyde here. Configuration is D and it is dextrorotatory compound. And in case of glucose also, the OH group is towards right hand side here. So it is also D plus glucose. Now let's see guys here. That was about there was some phenomena which was indicated that there was some reactions which indicated that glucose has stick form structure, that is glucose has open structure, but there are some reactions also which indicates that the glucose have cyclic structure. So let's see, we discuss one by one. First one is here, glucose do not react with CIPS base. There is an aldehyde group, but the glucose do not react with CIPS base, and it also don't react with hydrogen sulfide. Guys, you have already know what is CIPS base. Okay, CIPS base, that is in the chapter of amine. You have studied CIPS base. So, and CIPS base here is that indicated when any compound reacts with CIP base, then that indicates that there is an aldehyde group or a ketonic group in the compound. So in glucose there is an aldehyde group, but that don't react with CIPS base. So that's why here it indicates that there might be no aldehyde group. In addition to that, the glucose also don't react with hydrogen sulfide. Hydrogen sulfide, it don't react. Hydrogen sulfide, that means NaHSO3. So, okay, written here also. So glucose don't react with NaHSO3. So here, this reaction indicates that in glucose, there is no aldehyde group. Okay, second one. So there, in the previous reactions, previous one, that indicated that glucose has an aldehyde group, and these two reactions, that is reactions with CIPS base and with sodium hydrogen sulfide, that indicates that glucose has no aldehyde group. Next one, the glucose also pentacetate form here. When you have reacted the glucose with acetic anhydride, there was formation of pentacetate, and but that pentacetate do not react with hydroxylamine. So that indicates that the absence of CHO. Okay. Now glucose is existing in the two isomeric forms, that is alpha D glucose and beta D glucose. Here alpha glucose, that is method of preparation, alpha form of glucose is obtained by crystallization from solution of glucose at this one. You just read this one, not so much important. Okay. So here what's the indication? That there is no acylic carbon atom. Okay. There is no acylic carbon atom. That was the indication. So what is here? So what actually is? Just again draw the structure of glucose, and then after how the cyclic form of structure of glucose has been indicated. Let's see. So stick form of structure here, aldehyde group, 6 carbon. So 1, 2, 3, 4, 5 and 6. So this 6 carbon atom. Here at the third carbon there is an OH group, and in other carbon the OH group is towards right hand side, other side hydrogen. What happened here in the structure? The hydrogen at the second carbon atom that get bonded to this oxygen. Why oxygen here? Negative charge, here positive charge. And at the second last carbon here, the hydrogen is released here. So hydrogen get bonded to this oxygen. So that become OH. And here the valency of this oxygen atom become destabilized. When hydrogen will get bond to this oxygen, then that become OH. So double bond will convert it to single bond. So oxygen here, when hydrogen go from this oxygen, then the valency of this oxygen atom also become destabilized. Then after this oxygen will get bond to this carbon, because valency of this carbon atom also get destabilized. So what's the structure? Then after there will be a formation of ring. When this oxygen will get bonded to this carbon, there will be formation of a ring. So what will happen? So in the ring will be composed of 5 carbon atom. That is, inside the ring there will be 1 oxygen atom, since this oxygen get bonded to this carbon. So in glucose, inside the ring there will be 1 oxygen, and that will be 1 oxygen and 5 carbon, and 1 CH2OH that will be outside the ring. So let's see here how to draw the structure. So let's see here, this oxygen, that is this, and that is drawn by this side. The CH2OH, that is, this is the first carbon. This carbon here indicated. Here is oxygen, so it is first carbon. Here second, third, fourth, fifth, and the sixth CH2OH. It is outside the ring. So that is outside the ring. So that is CH2OH. This one is outside the ring. Now to this first carbon atom, watch out this. Okay, here this is first carbon atom, second carbon atom, third, fourth and fifth. So at this one here, this carbon, oxygen gone, so hydrogen will be here. Okay, first, second, third. Here this is the third carbon atom. At only this one, at the third carbon atom, the OH is towards left hand side. So here this OH will be indicated at the below side. Okay. Sorry. That will be towards above side. This OH will be at above position. And in other cases, the OH will be towards below side here. This is OH here. This is OH. So when we draw the Parenos form of structure of glucose, Parenos form of okay. there is here in this statement, that is glucose is of two types, that is alpha and beta. Alpha glucose and beta glucose here. So how to draw this one here? That is indicated by, that means the glucose will be alpha or beta. That will be indicated by at first carbon atom. The OH is below side, that is below side or above side. Alpha or beta, about that, and nothing else. The glucose is of alpha type or is of beta type. That is predicted by the fact that OH is at lower side, at the lower end or at the above one. So let's see here. So what's here this one? So OH group, when it is below, then it is called alpha, and when the OH is above, then that is called beta. So it is beta D plus glucoparanose. Okay, glucoparanose it is called because paranose form of a structure of glucose. Why paranose form of a structure of glucose? It is the structure of paran. In paran, there it is, the paran is composed of five carbon and one oxygen. So that's why the structure cyclic in the cycle, its cycle is resembled with that of the paran. That's why it's called glucoparanose. So alpha glucoparanose when the OH is below, and the beta glucoparanose when the OH is above. Okay guys, so that was the structure of glucose, that is stick form or the closed chain, that is paranose form of a structure. In the examination, the question in the 12th board has been asked a number of times, the structure of alpha D glucose or beta D glucose, and written that draw the structure of paranose form of a structure of glucose, alpha D plus glucose. Okay, so that was about the structure of glucose. In the next class, we will discuss about the fructose, about the structure of fructose and the other oligosaccharide, as well as about the polysaccharide. So it's all for this class. Thank you, Team Educate.